Hello everyone, welcome back to the video. I hope you have done some homework on reading on the heat energy release and also molar enthalpy change. So this video is going to demonstrate you a few calculation questions. We shall start off with this formula above. This is actually the quantity of heat energy released or absorbed throughout the reaction, represented by this symbol, equals to, this refers to the mass of water involved. You see, because most of the reactions here take place in water. So water is the medium that absorbs the changes in temperature. So we have to take the mass of water into account. The unit of it is gram. Then we multiply it with changes of temperature, which could either be an increase or a decrease in temperature. Unit that we are going to use here would be degrees Celsius. And then this letter C here represents the specific heat capacity of water. Now, always remember the specific heat capacity of water has a fixed value, which is 4.18. The unit is joule per gram per degree Celsius. This value represents saying that to change the temperature of every 1 gram of water by 1 degree Celsius, you need 4.18 joule of energy. Yep, so that's why 4.18 is being used here. So guys, please do remember this formula. Quantity of heat energy released or absorbed equals to mass of water multiplied by temperature multiplied by specific heat capacity. And in the end, the unit that we are going to obtain here is, can you see this gram and gram cancelling out each other? Celsius and Celsius cancelling each other. Therefore, the amount of heat energy released or absorbed has a unit of joule. Let's try on another question. When 2.5 grams of ammonium chloride is dissolved in 100 grams of water, the temperature falls by 1.7 degrees Celsius. You are expected to calculate the energy change for this reaction. Let's try. Amount of heat energy released equals to mass of water, 100 grams, multiplied by the change in temperature, 1.7, and specific heat capacity, which is 4.18 joule per gram per degree Celsius. The answer, 7,100 joule. Easily done. Alright, we shall now move on to a more complicated equation here, which is to calculate the molar enthalpy change of a solution, of a reaction, As you can see here, the formula is actually pretty much the same as the quantity of energy change, except that the first part is the same, except that now you divide by 1000 and you also divide by the number of mole of substances involved here, together with the unit kilojoule per mole. Just in case if you have forgotten how to calculate mole of a substance, number of mole of a substance equals to the mass of the substance used over the molar mass of the substance. We shall look at the next question to demonstrate how you calculate it. So it's Almost the same question. When 2.5 grams of ammonium chloride is dissolved in 100 grams of water, the temperature falls by 1.7 degrees Celsius. You are supposed to calculate the enthalpy solution for ammonium chloride. Okay, let's apply the formula. Enthalpy change here equals to same. It is, now this is mass of water, 100 grams, times change in temperature, 1.7, 4.18, always the same. Divide by 1000, always also 1000. Now this is the special thing here. The number of moles of ammonium chloride here. Question: how do you calculate the number of moles of ammonium chloride? Remember, it's mass divided by molar mass. Therefore, the number of moles of ammonium chloride used here is 2.5 grams. Molar mass, refer to your periodic table. Your periodic table. Look out for this compound ammonium chloride NH4Cl. NH4Cl. Okay, if you add up or total up the molar mass, you will see that equals to 53.492. Now you substitute this whole thing into here, and you will realize that you will come to an answer of 15 kilojoule per mole. Now, one thing you might want to pay attention to is the signage between, the signage in front of your value. It could be a positive or a negative. You have learned before that if it is an endothermic reaction, it is going to be a positive sign, but if it is exothermic, it is going to be a negative sign. In this case, your temperature falls by 1.7. That means the reactants absorb heat energy from the surrounding. Therefore, it is an endothermic reaction. Okay? So please make sure you put a plus sign in front of your answer. There you go. Got the answer. Now, just something different here. Occasionally, you probably get something like this, a question like this, but what is different is instead of them giving you grams of water, they will probably tell you that it's 100 ml of water. They will probably tell you it's 100 ml water. So what should we put here for the gram here? Yeah, please remember this, students. In chemistry questions, we always equate 1 gram to 1 ml. So if they were to actually give you 100 ml, you use 100 still. Just assume that 100 ml equals to 100 grams. Therefore, you also use 100 in your calculation. Now that you have learned how to calculate the molar enthalpy of change of a reaction, I'd like to also highlight to you that there are 3 main types of reactions molar enthalpy that you will be asked to calculate usually in the syllabus. They are the molar enthalpy change of combustion, molar enthalpy of a solution, and molar enthalpy of neutralization. As the name implies, combustion refers to the burning of a chemical in the presence of oxygen. Solution means dissolving a substance in water, whereas neutralization is you transferring the hydrogen ions from an acid to a base. So what I would like you to do is to look up the proper definition for all 3 molar enthalpies. Before we end this video, this picture shows you a simple experiment of how the molar enthalpy of combustion of this fuel could be calculated. As you can see, this is where the chemical or the fuel will be contained, yeah, and it's being combusted in the presence of oxygen. Oxygen is around, and whatever heat that is released from the combustion will be expected to be transferred into the water here, and therefore there will be a rise in the temperature as recorded in the thermometer. From then on, you will be able to calculate the heat energy release and also the molar enthalpy of combustion. It should be simple enough. Now another mini assignment for you to think of is, if I were to calculate the molar enthalpy of combustion using this experiment, how different would the calculated value be if you were to compare it with the theoretical value? Yeah, so do you think they would be pretty much the same, or do you think the calculated value would be lower, or would it be higher than the theoretical value? And try to also think of reasons why they are the same or why they are different according to your answer. Yep, so I guess that's the end for this video. Thank you.